Present. So it should be in the right view now. Can you see that, Tom?
Correct.
In the
Yeah.
centre. Brilliant. Okay, so good afternoon, everyone. I'm Emma Karoune. I've been really happy to hear all of the talks today. And like Sam said, I've been waiting since 2019 for this to happen because I think it's a very important conference. And actually, my talk today really complements a lot of the other talks, especially Sam's and Kayoung's, which we've just heard. And I think it gives them their work a little bit of context around reproducible research. As Tom said, I currently work at the Alan Turing Institute, which is the UK's National Institute for Data Science and Artificial Intelligence. And I work within the Tools, Practices and Systems programme. That is a lab firmly seated within the open science movement. And this programme develops tools for reproducible research, writes guidance and implements reproducible workflows in many different projects, such as health projects and data security and all sorts of other really interesting projects. Part of my work is being a core contributor to the Turing Way project. And this project aims to produce a guide that includes all of the resources needed for reproducible research in any field. And so today I'm going to speak today about reproducibility with my Turing Way hat on, but focusing on what is happening in environmental archaeology and how we can take steps forward in this particular issue. So I'm just going to talk very briefly about what the Turing Way is. And I'll put, you can see there's a link to the book on this slide, so you can go and have a look. So the Turing Way is an online book that includes guides for reproducibility, project design, collaboration, communication and ethical research. It involves a large community of researchers from lots of different fields that contribute to the resources in the book. And we work collaboratively and in an open source manner. So this means all of the work is openly available, so anyone can read, modify and reuse it. And this project is constantly growing as a resource made for researchers to use. And we want people to be using and adding to this resource all of the time. So I would actually be incredibly happy for more archaeologists to come and get involved in this project. So if you are interested in this, please do get in contact with me. Or also Esther is here today, who's another member of the Turing Way community. So I thought I'd start with what actually is reproducible research as defined in the Turing Way. And we say that it's work that can be independently recreated from the same data and the same code that the original team used. So this involves making your research transparent from its initiation to the final analysis. And this can actually be a really tricky thing to achieve. So there are currently concerns about a lack of reproducibility in all scientific research. And these concerns started in the field of psychology more than 10 years ago, with studies being retracted by journals and has radiated out from there into other disciplines. The phrase reproducibility crisis was coined in about the early 2010s. And a survey about reproducibility by the journal Nature, responded to by many scientists from a wide range of different disciplines, found 90% of respondents think there is a crisis of reproducibility in science, and 70% of scientists had tried and failed to reproduce another scientist's experiments. So these worries about a lack of reproducibility have led to the current expansion of the open science movement to try to deal with these issues. So is there a reproducibility crisis in environmental archaeology? And actually the only answer to this question at the moment is yes. Okay, so this is not as bad as it first seems, though, and as it does not mean that that we are all doing bad science or falsifying results. And seeing all of the great work today, we are definitely moving towards more reproducible ways of working. But it is a yesterday because we are currently unable to reproduce other researchers' work routinely. And this is due to a lack of open access, open methods, open data and open analysis code. So really, until we see the routine publication of fully accessible and transparent research, we will not be able to say that our work is reproducible. And therefore, it won't actually be possible to fully validate our research by peer reviewers. So how do we know currently that there is a problem in environmental archaeology? And I apologise for this slide because it looks really busy. So I'm going to try and explain it. So recent studies looking at data sharing have highlighted a need for improvement, as they have all shown a similar level of about 50% in published articles. However, for reusable data, the level is probably much lower, as shown by my own recent study looking at phytolith articles, in which reusable data was only 4% in a sample of 341 articles from archaeological and paleoecological journals. Also, publications are not routinely open access, and I found in the same study that just 14% of phytolith articles were gold open access. So this means that they would be open to everybody from the point of publication in the journal. But this did actually rise to 73% of the articles in my study for green open access, by which I mean a version of the article is available in an open online repository. So this could be a preprint or a postprint. And then I also found that full methods were often described, but many of these would actually be very difficult to use by other researchers to actually reproduce the study, as they were not full lab protocols that actually could be implemented by somebody. And adding to this is a recent study looking at the use of R scripts in publications by Schmidt and Marwick. And they found that in biological and ecological sciences, the use of R code is increasing quite rapidly, but in archaeology, it is only increasing at a very slow rate. And therefore, they concluded that its use is really only just emerging within archaeology. They found that 154 articles out of 43,000 roughly articles had cited R code. And this actually showed an increase in the Journal of Archaeological Sciences. And it was particularly in articles from specialists in stone artifacts and fauna remains. So good on you, zooarchaeologists, really. So how do we actually address this lack of reproducibility? Well, the only way to fully address this lack of reproducibility is to implement open science practices through research projects. So open science or open research or open scholarship, whichever term you prefer, is the opening up of every aspect of research by implementing all of these different practices in different ways. And this makes our research more transparent and available to others. And really the end goal of open research is reproducibility, leading to more sustainable research, and also to enable a more equitable, diverse and inclusive research culture. So I want to just explore this in terms of environmental archaeology. So really, what is reproducible research in environmental archaeology? What are the barriers to reproducible research? And then give some suggestions about how we can actually start to do reproducible research. So I think it's very important to understand, and often these terms are used interchangeably. So it's very important to actually define them. There is a distinction to be made between reproducibility and replicability in terms of data. So reproducible can be defined as when the same analysis steps are performed on the same data set consistently, producing the same answer, whereas a result is replicable when the same analysis is performed on different data sets, producing qualitatively similar answers. But I actually think it's very important to go further than this and actually distinguish and build robustness within our results. So what I mean by this is that the same data set is subjected to different analysis workflows to answer the same research question. So for example, using different pipelines written in R and then maybe another one written in Python, and then seeing if you get a qualitatively similar answer. And these robust results show that the work is not dependent on a specific analysis that is being performed. And I think this is where we need to get to in terms of the methods that we develop. So we then have confidence in applying them to archaeological materials. So I see there being two aspects to reproducible research in environmental archaeology. The first being the development of robust methods. So our aim should be really to build these robust methods that we can then apply confidently to archaeological deposits. And to do this, we need to construct much larger data sets by opening up our data for larger collaborative projects. And this is very important, as often methods are developed with very small data sets, and it is likely that this does not take into account enough variability of the biological organisms that the method is trying to identify. And it is very likely that the results would then not be reproducible and therefore not really sustainable and good to use, really. We should use also hypothesis-driven research where aims and objectives and methods are registered before analysis begins as a pre-registered report. And this promotes good practice in project design and leads to greater confidence in end results. And we need to use reproducible workflows for building methods so that they can be built on and used by others. This will make our methods much more sustainable in the future. And then the second aspect is the archaeological application of these methods, and we need to do this reproducibly. So this means having fully transparent workflows, so the methods, and I mean really protocols by that, so lab protocols, data, metadata, and code. We should be aiming for computational reproducibility. We need to train ourselves in analytical methods that are transparent, such as using R, and then the code for this analysis can be reported and reviewed, as has just been talked about in the last question session. Using point and click software such as Excel does not allow others to fully understand the steps taken in analysis, and unless they have actually been thoroughly documented, which is often not the case and actually very difficult to actually do. And therefore, these sort of point and click methods, they actually really complicate reproducibility and often hinder it being able to happen. So there is a spectrum of reproducible research that we can move towards. So at the moment, most publications would not be reproducible on their own. We need to start adding these full protocols, code and data in open repositories that are linked to the publication. But we also need to capture the computational environment so that the analysis using code and data are actually executable. And this is because analytical code needs to be run in a particular version of software that was used at the time of analysis. Otherwise, it will not really work or be reproducible. So this has to be recorded somewhere and it can be packaged together to run. And this would be the gold standard for reproducible research at the moment. And we need to start taking some steps towards it. So what would the barriers be to actually doing this type of reproducible research? So it does require additional skills. So who is going to train us, or do we hire specialists to help us, such as research software engineers or data scientists to move a bit more quickly? It requires a change of mindset. So it is a different way of conducting research, and so requires a new way of thinking about our research culture. Many outputs of reproducible research, such as open data and code, are not currently credited when it comes to job promotion and career progression. So although this is changing, I think, and in some fields, these skills are actually becoming mandatory, you will be held to a higher standard by being fully transparent. So you will be open to a bit more criticism than others. There is a publication towards novel findings, and this work is likely to produce more negative results, but actually these are as important as finding out something brand new. And it takes time to implement reproducible workflows, so we need to plan that work and maybe employ extra people. And then lastly, there does require additional infrastructure. And today, all the people have talked about how we are going to maintain databases and these types of tools as well. And there's definitely an issue with providing money for these services to be maintained. I'm going to have to talk a bit more quickly. So how do we actually do reproducible research? So there are lots of different ways to work reproducibly. There definitely is not just one way, and we have seen some of these today. You need to consider yours and your team's skill level and your discipline skill level, and also accessibility of everyone to these tools and software. So I think the key elements to think about when constructing your reproducible workflow are transparency. So you need to clearly document all stages of your work, so that someone independent can understand your methods, data and code. You can do this by setting up a working research compendium to produce this during your project, and I'll talk a bit more about those in a minute. We should aim to be as open as possible, but as close as necessary with our research. So when you make your research open depends on the type of research you are doing. In some projects, it can be done from the very beginning, and others will never be able to fully share data because of some sort of data sensitivity. However, this doesn't mean that it can't be reproducible. So you also need to consider collaboration. So open access for the work that you're doing with your team at the time during the life of the project, and also working with others needs version control to record the steps taken in the project. So I'm just going to talk about these two things. So research compendia or compendium is a set of files that accompany your publication and are held in an open online repository. So they can have this basic form, which is seen here in the diagram, to include data, analysis code, methods, and a README file to describe the project. And these files, you can actually set them up at the beginning of a project and constantly add to them, so that when you come to publication, they are already in place in the repository, and you can just literally link them to your publication when you submit your article. And then version control, this is about recording the changes made to files over the course of the project. And actually for reproducible workflows, this is really important because it creates transparency in the research. So you can go back to previous versions, you can look at the store of the history, it helps with collaboration in the project, and it also, very importantly, records contributions of the team so that all members get fair credit for their work. And you can do this in a very simple way with file versioning, so just naming your files, always simple tools like Google Drive and Dropbox. However, it's a good idea to go for more advanced tools such as GitHub or Subversion that offer much more features. And we've already heard a bit about the delights of GitHub already, and it's my preferred version control tool as well. So Git is actually the tool, which is the open source version control tool, but GitHub is the online interface that uses Git. So GitHub is free and it can be linked to other tools, as we've already seen. So tools, software, and repositories can be linked to it, such as Open Source Framework, RStudio, and Zenodo. So it's really good for reproducible projects because you can store all of your project documentation there. You can, it's got a fairly simple web interface for version control. It helps you to work collaboratively by setting up project pages, by creating issues, which are like tasks within the project, and also doing pull requests, which allows you to review other teams' work before you actually add it into the main repository. So I just want to show you what this looks like, although the last speaker showed you very well what this looks like, but this is a project I'm just starting on, the Fairfield Project. So turned over too many pages. So the Fairfield Project, as I said, is something I'm just starting, and we're setting it up from the very beginning as an open source project on GitHub, so you can go and look at it now. The project aims to improve the fairness of vital data, so the findability, accessibility, interoperability, and reusability of data. We're going to look at how fair existing data is and draw up guidelines for future data. So the project is managed in GitHub. So this gives us transparency and collaboration with version control. And all of the outputs can be archived in Zenodo for long-term storage with a digital object identifier. So others can cite our work easily. GitHub allows you to put a license on your work from the start. So if you look, it already has a license on there now. This is really important for open projects because it tells others how they can use your work. And I'm really happy for people to go there and use our repository as a template for creating one. We have a core team who you can see the names of at the bottom of the screen. But this is actually a community project. So we have a contributing guide on the repository to tell others how they can contribute from the beginning. And we can manage contributions through pull requests on GitHub to review contributors' work before it is added into the repository, but importantly, give them credit for the work that they do as well. There is no data or analysis at the moment because we haven't done that, but we have planned that these files will be added when this work starts. And we also aim to package the analysis to make it executable using a tool called Binder, which if you're interested in Binder, you can contact me about that. And so this will actually create an executable, reproducible workflow that you will just be able to go and it creates like a little Jupyter notebook, so you can actually go and see the whole analysis, and it will demonstrate it for you, and you can reproduce it. So the Fairfield Project is just starting. If you're a phytolith researcher, look out for it, because we're going to be sending out a survey soon to ask you about your data sharing and your opinions on open science. So I'm doing a bit of advertising now, I apologise. My second advert is the AEA membership survey will be coming out soon. And please look out for the questions on open science skills training, because we want to know about what skills do you want to learn, whether it's sort of introductory or more advanced skills, and how much time do you have to spend training, because we're considering running a workshop later this year to look at and train us all in some open science skills. And lastly, just some thank you. So thank you to the Turing Way community, particularly the project lead Kirsty Whitaker and community manager Malvika Sharan, and then also the Fairfield team, core team, which you can see there. And then also thanks to Open Life Science, Jill Campbell at Historic England, and the International Phytolith Society that have helped us to apply for funding for the project. So thank you.